In the lab this week, we are learning how to use a compass and a paper map to navigate. Now, that for some of you will be a brand new experience if you've never used a compass before. And so I want to talk just a little bit about how this thing works, how you read it, and then talk a little bit about how we're using it in the lab to determine the direction from one location to another. So the first question is, how does this thing work? How do we tell direction with a compass? A long, long time ago, and I do mean thousands of years ago, people figured out that if you magnetize a piece of metal and let it float, it will align itself with the Earth's magnetic field. So one end will point north and one end will point south. In a compass, we're just exploiting that. We've got this thing sort of floating around in some liquid. And with this compass, like many or most compasses, the north arrow is the red tip of this thing. So when you're looking at the compass, it is pointing north with the red tip. So if you just leave that thing alone, it will gravitate, or it'll be drawn magnetically to the North Pole, or not quite the North Pole, the North Magnetic Pole, which where we are is about 11 degrees from the North Pole. So the way to think about this is, if you look at the ring around the compass, it's got all these numbers and it has an N. So once you have that compass still and it's pointing north, you can align your device with it. I think it's a little easier to read. I don't know if I can do this with one hand. If you take that N arrow and point it at the top of the device, it's a lot easier to see. Now, I don't quite have that lined up, but you get the point. The arrow is facing north. I've got the N over it. And so now I can read things relative to that. Now, if I wanted to know exactly where north is, I would need to turn my compass just a little bit, 11 degrees west of north. And now north would be where the N arrow is facing, not the compass itself. We're not going to worry about that too much in this lab. I just want you to have a basic understanding of how we navigate with a compass. Now today, on my wall behind me, in addition to some art my daughter's friends left behind, I've got a map of D.C. I live just outside of the capital in Montgomery County, Maryland. And I'm going to use this as an example. We've just learned how to get the compass facing north. Now, there are lots of ways to use compasses, but if you're a rookie like me, I'm no pro. Talk to your TAs if you want to know better and more elaborate techniques. Once you have the compass facing north, what I like to do is put the map on a sheet of paper and turn it until the side of the map and the compass are both facing north. Now, right now, I've got this thing vertical, and so the arrow is not facing north, but pretend that right now that red arrow is facing straight up, and I have it aligned with the side of the map. Now, most maps have north at the top. That's not always true, but for any map that does, this technique works. So now that we've learned how to determine what north is, and we have this compass aligned with the side of the map, so the top of that compass is pointing north, then I can measure the direction relative to this point to another point. The way we determine direction is using a circle. North is the top of a circle around the midpoint of that compass, and north is 0 degrees. It's also 360 degrees. So north is a special measurement because it's where the circle closes itself. If you go around the circle, you'll see that due east is 90 degrees, due south is 180 degrees, and due west is 270 degrees. Northeast is 45 degrees. Southeast is 135 degrees, and so forth. So you can figure out what those cardinal directions are, the points of north, south, east, west, and northwest, northeast, southeast, southwest. But we can be more specific than that and say what the precise degree angle it is from one point to another. And the way we do that is I'm going to place a straight edge on this compass at the center of the compass at the Library of Congress, and it's facing north, so 0 or 360 degrees is the top of this compass. And I'm going to draw, or in this case, place a straight line from it to the point I'm interested in measuring the angle of. And this number, where the straight line crosses the edge of the compass shows me the degree measurement. In this case, it's about 325, 330 degrees. West is 270, due north is 360, so we're about northwest, which is what you can kind of see on the map. DC is an easy town to navigate because there are so many roads that angle off in cardinal directions. But that is how you determine direction using a compass, and you'll be practicing this skill in the lab prior to going out in the field and orienteering for a while. The other thing you might ask is, well, how far is it from this point to this point? Now, somewhere on the map, if it's a good map, there's a scale, like right here. And this scale is telling me that this distance, which I measured as about 2¼ inches, is about 8,000 feet. So whatever that is in dog years, 1 1/3 miles, 1 2/3. And so 2¼ is 1 2/3. I'm going to divide that total. I'm going to divide the total distance from point A to point B by 2¼ So it's about 8.5 inches. And if I divide that by 2¼ I'll get about 4. It's about 4 miles away, little less, as the crow flies, from point A to point B. Now, in the lab, what I'm asking you to do is use that very rough scale to estimate. It doesn't have to be a perfect measurement, the distance from each point to each other point in the map as the crow flies. Now, we're doing that way because pretty soon we're going to work with GPSs, and we'll repeat our steps using a GPS, and we'll actually track the route we take to get from point A to point B, which is probably in your case quite different from the straight line direction.